Yes, is it audible? No?
Yes, sir.
Yes, okay, fine. Good morning to everyone.
Good morning, sir.
Yes. So, what all we have studied in the last class? Yes, I had given one homework, correct? Na? Have you solved? Have you
Yes,
got the
sir.
same answer?
Yes.
Yes. Is there any doubt? Okay, fine. Then we will move on to the next chapter. That is chapter number. Chapter number 7. So, unit number 7. Okay, this is one big chapter. Afterwards, there is only 1 hour, 2 hours subject. Okay, read down. Work energy methods. Work energy methods.
सर
हाँ, yes.
हुए हुए चैप्टर की रिवीजन कब कराओगे?
What? क्या चाहिए?
रिवीजन सर, हुए हुए
रिवीजन कौन सा चैप्टर?
चैप्टर
कौन सा चैप्टर का रिवीजन?
ऑल वो आप बताए थे ना, हम लेंगे.
Yes, yes. We'll take first. We'll complete the syllabus.
यस सर.
You come to the college. Where are you right now? What is your name? What is your name? Huh? What is your name? Hello. What is your name?
पृथ्वीराज पाटील सर.
Prithviraj Patil. Yes, yes, wait. So first I will complete the all these chapters. Okay. Within 2-3 days, I will complete all this one. Then afterwards, we will do the revision. That is multiple choice question and all. Okay.
Yes, sir.
Yeah. First, I will complete this one. Okay. This is also important. In the multiple choice questions, you may come across this also. Okay. First of all, we will complete as per the syllabus.
Yes, sir.
Afterwards, we will take that one. Okay. Is it visible now? Screen?
Yes.
Yes, sir.
Okay, so look at the unit 1. We have completed all the 4 units, and unit 2 we have completed kinematics, kinetics, correct? Then we are coming to the work energy methods. Okay, so in the work energy method, what we are studying is here we are studying about the already you learned in your that is 12th classes. Okay, about work energy and power. Okay,
Yes, sir.
potential energy we are studying, kinetic energy of linear motion we are studying. Then principle of the conservation of the energy, work energy equation we are studying. Okay, only this much is there in this chapter. So, then can you tell me what is work? Force into displacement.
Force into displacement.
Work done by the
Sir,
force.
sound.
Disturbance हो रहा है क्या?
Break होते sound.
Okay, maybe network problem, either from my side or from your side. Okay. Okay. What is work? Work is nothing but it is a work done by a force on a moving body. Is defined as the product of force and displacement in that direction. This is important. In that direction is very, very, very important. Okay. Suppose think that there is one body is there. I am applying a force on this body. Okay. After applying the force, yes, concentrated the screen. After applying the force, the body got displaced at a distance. Yes. Okay, the same body is here. Now you can tell that the work has been done. Okay, how much is the work? That is force multiplied by this distance in that direction only. Okay, that is called as force into displacement. Then unit of work is what? Newton meter, because force is in Newton, distance is in meter. So unit of work is Newton meter, or this unit Newton meter is also called as joule. Joule. Okay. Then 1 joule is defined as the amount of work done by the 1 Newton force when body moves through a distance of 1 meter in that direction of force. Okay. If you take 1 Newton force is applied on a body and displaces a distance of 1 meter distance. Okay, then you can call it as 1 joule. 1 joule. Are you getting all of you? Yes. All of you read on the definition. Read on the definition. Work done by the force on a moving body. Moving body is, see, this is a dynamic part or a static part. On a moving body, it is a dynamic part only. Hmm? 1 joule. Read on. What definition for 1 joule? Read on the definition for 1 joule. You should know, that's all. After that one, read this diagram. This is important. आपको समझ में आएगा नहीं? Will come to know now. So this is horizontal P1, this is P2, this is P3, and this is P4. So this same way, P1, P2, P3, P4. Okay, the distance between this point to this point is S. The distance between these 2 points is S. Okay. Now I will take a tabular column. This is a force, and this is work done. Work done. Diagram. Okay. See, initially the object is at a point A. Object is at a point B. Now, after application of the force, the object has moved to a point B. But distance is how much? Yes. Okay.
Yes.
I have to calculate the work. Okay. Because of P1, so force is I am taking P1. Okay. So along the P1, so what is the distance? A to B. What is the distance? Along the P1. It is S. So how much is the work done? Work done is equal to P1 into S. Is it correct? So
Yes.
this S is along the direction of the P1. Correct? Okay. Next, I will take P2. P2 is in this direction, but displacement is in this direction. That is, both are in the same direction. Both
No.
the same or opposite direction. Opposite direction. Force is P1, but the displacement is S minus S. What is the formula? Minus work done is minus P1 S. Are you getting? Why work is negative? Why work done is negative? Because the force and the displacement are opposite to each other. They are not along the direction. Next, I will come to the point P3. P3 point. Okay, so P3 is in this direction. So along the P3 direction, whether the A is moved along the P3 direction? Is it moved in 90 degree? Whether it is not moved. Okay, it is not moved. So P3 into S, S is equal to 0. Whether vertically, the point is, see, now it is in horizontal direction. In case if it is displaced at this point, there is some amount of रहता ना, so अभी नहीं, so P3 into 0, then that is equal to 0 along the direction of P3. Flip it. See, in case अभी A point इधर है, exactly horizontal इधर आ गया. Okay, so force is P1 ऐसे हैं, so S is ऐसे. So what is work done at this point? P1 into S आ गया. Suppose P1 is in this direction. Suppose P2 is in this direction, but S is in this direction. So what is the amount of work done? P2 into S. Suppose in the P3 is here. Okay, so along the vertical direction, is it moved?
No.
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 It's not moved. Displacement is how much? 0. So P3 into 0. It is equal to 0. So P3 into this is. Next, abhi dekho. P4. P4 is in this direction. Okay, so I will come to the point B. Now the distance along the horizontal is S. I want in the direction of P4. So can you tell me what is the direction in the direction of P4? Along the horizontal it is S. See what I am telling. The force is, this is force P. So this is the distance S. Along the horizontal it is S. Along this direction it is theta hai. So how much is along this direction? S cos theta. Yes, all of you are getting S cos
Yes,
theta.
sir.
Then
Yes, sir.
force is P4. Along the direction of the P4, how much is the displacement? That is S cos theta. Is it correct? Yes, this is P S cos theta. Or if you take the S is 1, S is then P cos theta you can take. Okay, P S cos theta. This is for the P4. Okay, so write down this one. Yes, correct. P2. This is P2. P2, correct. Are you getting all of you? This table. So
Yes.
from the definition, we can write work done for all these.
सर डायग्राम ड्रॉ करनी है क्या?
Yes, diagram draw करो. Then only you will get understand. नहीं तो आपको समझ में नहीं आएगा. Which is P1, which is P2, y minus, y P3 is 0. You will not come to draw this diagram. Yes, completed. Draw rough diagram. Don't take pencil, scale, angle. Just for your understanding purpose, I have drawn. Yes.
Yes, sir. Complete.
Can I go for next slide?
Yes, sir.
Okay. So we'll come to this energy later. So write down one more point. Okay, energy, write down. Write down energy. What is energy? Energy is defined as capacity to do work. Capacity to do work. There are many forms of energy like heat energy, mechanical energy, and chemical energy, or etc. So what are these many mechanical energy? Mechanical energy is mainly classified into two forms. One is potential energy and one more is kinetic energy. So this potential energy is, what is this one? The capacity to do work due to the position or elevation of the body. Due to the position or elevation of the body. Then potential energy is also defined as energy possessed by the body due to its position. Okay, so these are the energy and the classification of energy. Okay, write down energy. the body of weight W held at height held at height h possesses an energy possesses an energy. Okay. Potential energy is also defined as a energy possessed by a body due to its position. A body of weight W held at a height h, then what will be the potential energy? H. Okay. If I take the body, okay, this is a body. Okay, this body is having fully water. Okay, then how to? Okay, this is having. Okay, think that this is water level. Okay, this is water level, and the height is h, and its weight is W. Then how much is the potential energy at this point? That is W into h. Weight, weight of the body into height. W into h. This is called as potential energy. Yes, yes. As the height increases, the potential energy increases. Ah. Just completed. You
No,
take this
sir.
diagram. You take this diagram and you take that point. A body of weight W held at height h, held at height h, possesses an energy W into h. From tomorrow, your IAC UT3 will just start. Okay, your chapter is 5th and 6th chapter. Okay, kinetics and kinematics, both chapters. You go through the multiple choice questions. Okay, so that your UT is based on a multiple choice question. First go through all the MCQs. It is already uploaded, I think. Check it. Okay, finished.
Yes.
Yes, sir.
Yes, sir.
Okay. So after potential, see here is given. The potential energy possessed by a body of mass m. I have taken weight. Okay, placed at a height h. Then potential energy is equal to mass g h. What is mass into acceleration due to gravity? Weight. Okay, what is weight? W weight is equal to m into g. Okay, so we can take mgh or you can take weight into h. What I took there weight W into h I took. If there is a mass is given, then that mass is multiplied by the g, then into h, that will give the potential energy. Then one more is kinetic energy. Kinetic energy is the capacity to do work due to the motion of the body. Due to the motion of the body. Kinetic energy is also defined as the energy possessed by a body due to its motion. Okay, so these points are important. Then you know that what is the formula for the kinetic energy?
1 of
One half
There is
square.
a derivation in your 12th class, but now don't take that derivation. Just you should know kinetic energy is equal to, okay, write down all this one. Kinetic energy is equal to half m into v
V
square.
square.
Okay. M is the mass of the body, and v is the velocity. So this can also be written as half. M is nothing. We have written W is equal to M into G. Correct? What is M? M W by G. W divided by G into B square. ऐसे भी लिख सकते. See why I am giving all these definitions, because in the multiple choice question he is going to ask directly what is power, what is energy, what is work, what is potential energy, what is kinetic energy. Rate of change of work. Roll number 64. Why you are missing so many classes? कल कहाँ पर थे? I don't want any reason. Sincerely attend करने classes है ना? Friends का कैसे sincerely attend करते? See hardly 1 week afterwards there is no my class. There will not be any lectures. हाँ. क्या बोले? हाँ हाँ. वर्क क्या है? अभी देखो एक पॉइंट है बॉडी, ये एक बॉडी तो डिस्प्लेस हुआ तो देन दैट इज वर्क इज डन, वर्क है हो गया उधर, ऐसे बोल सकते हैं. अभी नेक्स्ट पॉइंट इज वर्क है, वर्क दिस इज पावर है ना. सो एनर्जी मतलब क्या है? देयर आर टू टाइप्स ऑफ एनर्जी, मैकेनिकल एनर्जी, पोटेंशियल एनर्जी एंड काइनेटिक एनर्जी. पोटेंशियल एनर्जी मतलब अभी देखो एक बॉडी कंटेनर है, कंटेनर में एक मटेरियल स्टोर कर दिया, कितने हाइट तक स्टोर किया? दैट द एनर्जी व्हिच इज पोजेस्ड बाय इटसेल्फ ओनली. द मैटर में भी द मैटर कितना हाइट में है, सो वेट ऑफ दैट बॉडी इनटू एच. अभी देखो सो वे आपका पाम ऐसे रखो, इसके ऊपर 1 kg का आयरन पीस रखते हैं, यू फील दैट देयर इज अ वेट. व्हेन यू आर फीलिंग द वेट इज transferred from the body to on your palm. Okay, then only there is a potential. It is not moving anywhere, it is staying in the static only, but that weight is coming from the top to bottom. That is the height is increasing. Again you increase the height, again the weight is increasing. Weight is increasing because of height is increasing. Then as a result potential energy is also increasing. As the height increases potential energy is increasing. Okay, that is. Then again one more term is kinetic energy. Here potential energy में क्या हुआ था? Because of static, the body is static but the height was fluctuating. In the second case body is moving. As the body is moving there is a kinetic energy is done, but how much it is? Half mv square, but that mv square there is a derivation, but that derivation we are not doing. Okay, yes, is it clear?
Yes, sir.
In the mechanical energy there are two parts, one is potential energy and one more is kinetic energy. The potential energy is due to the matter, due to the substance only. Okay, and as the height increases the potential energy increases. Okay, so if you consider this is the place, if you consider this is a container, the water is here only. Now height is this much, the potential energy is equal to weight into h. Okay, h1. If the height is comes to the h2 point, h2, so potential energy is equal to w into h2. As the height increases potential energy increases. Now coming to the second point, kinetic energy is of mv square. Okay, mass is fixed. As the velocity increases your kinetic energy is increasing. As the velocity decreases your kinetic energy decreases. Okay. So in the exam what he is going to ask? He is going to ask what are the different types of energy, kinetic energy and potential energy. Then what is the unit for the work for the energy. Then next point is power. So you know that work is equal to what? Work is equal to what? The force into
Force into
displacement.
displacement.
Force into displacement. So if you do the rate of change of work with respect to time, then that is called as power. Power is defined as the rate at which the work is done. Okay, the unit for power is watt, and it is defined as 1 joule of work is done per unit time or per unit second is called as work. So if you take W is equal to F into S, then dW by dt is equal to F is constant force. F I will take outside. So ds upon dt. So that is equal to, this is power and force is in Newton, distance is in meter divided by time t. Okay, you can take here F into V also. ds by dt is V. Okay, this Newton meter, this time is in second. Okay, second. So this is the unit for the power, and this Newton meter per second is also called as watt. Okay, watt directly he has taken. Okay, so I can define 1 watt. How to define 1 watt? 1 watt. So if I consider 1 Newton of force, force is equal to how much? 1 Newton of force. Okay, if it applies at a distance of 1 meter per 1 seconds, 1 meter per second, then that entire is called as 1 watt. Okay, write down this definition. Power is defined as the rate at which work is done, or else the rate of change of work, or else the time rate of doing work is also called as power. Okay, you should know rate of change or time rate at which work is done. Next, unit of power is watt, and it is defined as 1 joule of work done, 1 joule of work per unit time or second. See, what is work? I took force 1 Newton and 1 meter. What is 1 Newton? 1 meter means 1 joule. Okay, 1 Newton, 1 meter means what? It is 1 joule. Okay, 1 joule. So here the definition is like that only. 1 joule of work done per unit time. 1 unit time is unit second. 1 joule per second. 1 joule per second is also 1 watt. 1 watt. Then this is also 1 Newton meter per second is also 1 watt. Watt का मैं small w only. Okay, small w. Or work is capital W. Okay, power is capital P. Okay, energy is capital E. Okay, so one more point. Read on one more point. Note, horsepower is the unit of power used in MKS system and FPS system. You know SI system, MKS and FPS. So maximum in the problem he may give horsepower. So horsepower is, it is MKS system or FPS system. Okay, one metric horsepower is equal to 735.75 watt. Right. So one British horsepower is equal to 745.8 watt. Okay, he will give 1 MHP. He will give 10 BHP. Okay, you should know British horsepower and metric horsepower. One metric horsepower is equal to 735.75. And 1 British horsepower is equal to 745.8 watt. Okay, now I will do the revise. So first you have done work. What is work? Force into displacement. What is unit? Newton meter. 1 Newton 1 meter is equal to 1 joule. Is it correct, all of you? Yes. Coming to the second, energy. What is energy? Capacity to do work. Okay, so in the energy there are two parts. One is potential energy and one more is kinetic energy. So I will take potential energy, that is W into H or mgh. Okay, so if I take a W is in Newton, H is in meter. Okay, then kinetic energy, that is half mv square. Mass is in kg, velocity is in meter per second. So kg meter square per second square, you can. Then coming to the power. Power is equal to what? Rate of change of work
Rate of
done.
change of
Okay.
work done.
So work done divided by time. Correct?
Time.
So work
Yes.
is what is Newton meter per second. ऐसे भी बोल सकते हैं, नहीं तो 1 joule per second भी बोल सकते हैं. This is equal to 1 watt. Is it correct, all of you?
Yes,
Yes.
sir.
Again, this power can be expressed in a MK system or FES system. 1 metric horsepower is equal to 735, 1.75 watt. Then 1 British horsepower is equal to 745.8. Is it clear, everyone? Okay. These 2 points are very, very important for the multiple choice concept. Okay, he is going to give. Write down, star mark karo. Okay, important लिखो, but you have to be remember 1 BHP and 1 MHP. Okay.
सर पावर का फॉर्मूला क्या है?
Power का formula.
Yes.
Power is work into
W upon
the time rate of work. Time rate of work means what? Time rate of see, already work is there. I have to do the work per unit second. Work is there. Work is equal to how much? 1 force into 1 meter. Correct है ना? So per unit time, every 1 unit time, I have to do the same work. Okay, it means per time. Rate of change of work done. Okay, power का unit क्या होता है? Newton meter per second. That is called as Newton meter क्या है? Joule per second. So this entire term is called as watt. समझ में है ना?
yes sir.
Yes. So then there is a derivation for this one, that is work done by energy. So that derivation is not there for your right now syllabus. Okay, don't worry about the derivation. Then again, work energy equation. Yes, this is important. Work energy equation. What is this one? The work done by the system of forces during the displacement is equal to the change in kinetic energy of the body during the same displacement. So suppose consider this is one body. इसके ऊपर there is F1 force, F2 force is there. Okay. After this one, the body will come to this point at a distance of displacement. So how much work is done? Okay, you have to calculate individual work done is equal to change of kinetic energy. You know kinetic energy. What is the formula? Half
One
mv
half
square.
mv square.
Change in kinetic energy मतलब that is final kinetic energy minus initial kinetic energy, that will give the change in kinetic energy. That is the work. That is the important for the work energy equation. Okay, so write down all of you. First write down. This is important. Work energy equation. Work energy equation. Work done by the system. Important. This is also important statement. Work done by a system of forces. Work done by a system of forces during a displacement. During a displacement is equal to change in kinetic energy. Change in kinetic energy of the body during the same displacement. During the same displacement. Okay. So draw this diagram. All of potential energy will not change because initial कितना रहता ना potential energy है, final भी वैसे ही रहता because height will not change, mass will not change. Okay. Huh? Ball. Because of the potential energy is because of its matter. कितना matter है and its height. That is constant, no? स्टेबल अभी एक बॉल लिया, इसका हाइट अभी भी इतना ही, अभी डिस्प्लेस करने के बाद भी इतना ही, हाइट नहीं चेंज होता, तो पोटेंशियल ना, so kinetic energy will change. Okay, this is the body and it is the distance ds. Okay, so looking at the figure, what are the forces which are acting on the body? F1, F2, F3. Okay, and it is a self weight also. By considering all these force, can I take one resultant force? Abhi individual forces hai. Okay, after some point of time, the body is displaced at this point. Why it has displaced? Because of resultant force. That resultant force is because of all the individual forces. Okay, can I take that resultant force as R? R into ds is the displacement. This is equal to, okay, then final change in kinetic energy. So change in kinetic energy, kinetic energy. So what is that one? Half, mass is same, both the side. Okay, initial and final. Then V2 minus V square minus V1 square. Okay, so individual bracket square नहीं होता है.
फास्ट हो रहा है.
Half mv square minus half mv square. Bracket square was of but then that is changing. Okay, this is one. Okay, take this diagram.
सर
Don't take this one. Only this one. Okay, tell me. Yes,
सर बहुत फास्ट हो रहा है.
बहुत फास्ट हो रहा है क्या? नहीं नहीं, इधर भी क्वेश्चन पूछ रहे हो ना, उनको आंसर करके आपके पास आ रहा है ना, इसके लिए ऐसे लगा. Okay. Yes, you have to draw this diagram. आपको चाहिए तो, नहीं तो directly you can write this one. So R into ds, R into ds is equal to change in kinetic energy. Distance is how much is the distance? I have taken here small distance. See, work energy equation. Okay, in the multiple choice question, he may ask work energy equation is what? That is, what is the work energy? Force into distance, displacement is equal to half m v2 square minus v1 square. Or you can also tell force into displacement is equal to change in kinetic energy. This can be more useful than the D'Alembert's principle when we are not interested in the finding the acceleration. Yes, whenever you want to determine the acceleration, you have to use the D'Alembert's principle because of inertia force. Okay, now here we are not interested in acceleration. We are interested mainly in finding the velocity and distances. Okay, that's why final resultant force into distance is equal to half m v2 square minus v1 square. Is it clear, all of you? Yes.
Yes, sir.
Yes. See, there is you know this one. So F is equal to mass into acceleration from the Newton's second law of motion. Okay, you know from the equation of motion, v square minus u square is equal to 2as. Yes, a is equal to, from this equation, v square minus u square divided by 2s. Okay, again this a is substituted in the equation number 1. Okay, so this one is equal to, again 2s, he has taken only as common, m and m multiplied inside, mv square minus mu square divided by 2s. Okay, yes, he has multiplied to the f side.
आज पप्पा भर का
Roll number 33, Kunal. Aman, please mute yourself. Aman. F is equal to, F into S is equal to half mu square minus half mu square. V is final velocity, U is kinetic energy, initial velocity. Okay, don't worry about the derivation, but this is a way to derive this form. Yes. Same. Okay, we. So F into S is equal to work done. Then we will solve the problems. See, everything is problems. Okay. That completes entire. Okay. Okay. Take down the problem now. Theoretical part only work on this one only that much. But problems are there. Varieties of problems are there. Yes, all of you take down. A body. A body weighing 300 Newton. Weighing 300 Newton is pushed up a 30-degree plane by a 400 Newton force acting parallel to the plane. Full stop. If the initial velocity of the body is 1.5 meter per second and coefficient of kinetic friction is 0.2. What velocity will the body have after moving 6 meter? There is a 30-degree plane. On this 30-degree plane, there is a one block. This is the block. Okay. A force P is applied along the plane direction. How the weight is act on this body? Downward. Okay. So this is plane is making an angle of 30 degree. Okay. Now I will draw the two planes. One is parallel to the plane and one more is perpendicular to the plane. Then can you tell me how much is this angle? That is weight done by vertical. How much is 30 degree? 30 degree. He will not be given. Okay, you should know this one. Then weight is given. How much it is? 300 Newton. Then F is equal to F is 400 Newton is applied. 400 Newton. See, a body of weighing, he has already given the diagram. Body of weighing 300 Newton is pushed up 30-degree plane by 400 Newton force. Okay, this force is 400. If the initial velocity of the body is how much? 1.5, then coefficient of friction is given. What will be the velocity? What will be the velocity after the body has moved 6 meter? Okay, you have to apply work equation. Okay, so total force into displacement is equal to change in kinetic energy. So that you will get the formula. Okay, so first of all, see, when the body is resting on the plane, what are the forces? Forces are, one is normal direction. Then the body is moving upward direction. There is a friction. It is in a downward or upward direction? Downward direction. The downward direction. So this will be the frictional force. So I will take this is FR, frictional force. Okay. So solution. So how to find out the value of N? How to find out? Yeah, is it necessary to find the value of N?
Mechanics.
No, sir.
Yes. In order to find out frictional force, you should know the value of N. No. So
Yes.
N find out करने का है. Yes. So summation of forces normal to the summation of forces normal to plane is equal to 0. Okay, what are the normal? N is moving upward direction. Yes, plus N. Plus N. Then weight is acting downward, but with respect to normal, that is downward. What will be the W?
300 cos 30.
Minus 300 cos 30 is equal to 0. Then calculate the value of the N value. Yes, calculate the value of N. Yes, 259.81
249.80.
or 80. So this is the value of N. Then how to calculate the F value?
Laws of mechanics. F is equal to
Frictional. F is equal to mu from the kinetics laws of friction. From laws of friction, F is equal to mu into N. So I want the value of F is nothing but friction, correct? Don't get confusion. Friction. Mu is given 0.2. Okay, N is calculated 9.8. So what is the value of friction?
51.96.
51.96 Newton. Okay. So this is the
51.96.
value of friction. Okay. Then again, what he is given? He has given initial velocity u. Okay, all of you. Okay, write up this. Okay, don't write. Okay, concentrate now. Okay, what is given? Initial velocity is given u. How much it is given? 1.5 meter per second.
1.5
Meter per second. What is asking? He is asking final velocity is how much? Correct? What is the distance? It is covered. He has not given. Distance is given.
6 meter.
Yes, is equal to 6 meter. Okay.
6 meter.
Equating work done. Equating work done by forces along the plane to change in kinetic energy. Okay, what is the forces kinetic energy? Okay, first what do I have to take? I have to consider all the forces which are moving along the parallel direction. Okay, the body is moving in horizontal direction or vertical direction. Along the plane, it is moving upward direction, correct na? So I have to consider forces parallel to the plane, correct? So that is equal to all summation of forces parallel to the plane into displacement is equal to half m v square minus c square. Is it correct?
Yes,
Yes.
sir.
What are the forces which are parallel to the plane? Now coming to the 400 moving along the direction. Yes, plus or minus?
Plus.
Plus
Plus.
400.
Minus.
Next, friction is minus 51.96. Then weight is yes 300 sin 30 degree, correct na? So minus 300 sin 30 degree. Is it understood by all of you?
Yes,
So this is net force.
198.0.
Into negative. See, weight is acting opposite to the motion. Opposite to the plane motion. Next, into distance kitna hai? He has given after covering 6 meter. 6 is equal to half. What is m? Body ka weight 300. It is given weight. I want kg. Yes. 300 divided by 9.81 into what is the value of V, I have to determine V square minus U is 1.5 square. Okay. So calculate and tell me the value of V. So only this much calculate left hand side. Only calculate left hand side.
One
And
one
all.
eight.
Okay. Multiply by 2 into 9.81 divided by 300. I am getting this is 77.71 is equal to V square minus U square, 1.5 square. Is it correct? Check it. Okay. So final value B is equal to, tell me B value.
Correct.
Correct?
Yes.
V value 8.4 to 8.942. Is it correct? Check it. Eight point nine four two. Correct. Okay. So this is the way you have to do. See what is given. Try to understand the problem first. Okay. There is an inclined plane. The body is moving upward direction because of he has given the initial force. How much is the force given? 400 Newton. Initial velocity is there 1.5 meter per second. Okay. I say force. I say there. It is. I say move. Up to 6 meter. Okay. The velocity is final velocity कितना ही पूछ रहे हो. Okay. So that is weight is given. Okay. There is a coefficient of friction is given. Okay. First, what you have to do? You have to calculate the normal reaction. Then you have to calculate frictional force. Then you have to calculate the summation of forces parallel to the plane. That will give the net resultant force. That is multiplied by S. So this S is nothing but displacement. Okay. Then that is equal to by equating your kinetic energy, change in kinetic energy, so that you will get the answer. Is it understood, everyone? Yes. Right on. Now. हाँ. टाइम हो गया. मैं और एक प्रॉब्लम लेने के सोच. ओके. हाँ. ओके. Three, four, 9 present. 10. 11. 15. 16. Who is 16? 20. 24. 24. 29. 43. 43 present. आपका नाम क्या है? 43 number name Sakshi. 52. 52. 53. 53. 53. 54. 54. 61. 63. Present. 64 present. Okay. So option numbers 10, 16, 53, 54. 10, 16, 53, 54. Okay, these are option numbers. Okay, so we'll stop now. We'll continue in the next lecture.
सर
Okay. हाँ, tell me.
कल के होमवर्क के आंसर बताइए ना।
हाँ, आंसर दिया था ना कल का होमवर्क का?
नो सर नहीं दिया था।
नहीं दिया था? एक मिनट, just a minute. M is equal to 500, I is equal to 5000, वही है ना? Yes.
नो सर
400, omega is 280 RPM, correct है ना? वही है ना?
No.
Correct. What was asked? Tau was asked, correct? What is the value of tau? What is the value of tau? Tau is equal to कितना आया? 523.33. हाँ, one more problem है ना? Torque, okay, that is equal to 2 is equal to 245.76.
हाँ यस सर
How many problem? कितना प्रॉब्लम्स दिया था? एक ही दिया था, ठीक है, करेक्ट. Tau is equal to correct. Tau is equal to 245.76 Newton meter. Is it correct?
Yes, sir.
Next, change in kinetic energy. Yes, 941.85 is correct. Okay, kilojoule. Okay. Angular momentum पूछा था? Yes, okay, that you calculate. I have not calculated. These are form. Okay, we'll stop now. We'll continue in the next class. Okay, thank you all. And one more thing, I have uploaded the assignment number 5, 6. 6 पे upload किए? 5, 1. Okay, today I will upload 6 and 7. We'll stop. 4 and 5 I also uploaded.